All right, in this lesson, we're going to be looking at some more graphs of polynomials. Just in general, an even function looks like a quadratic function. Looks like has a lot of the same characteristics as a quadratic function. All right, so a parabola, the end behavior for parabola, the domain for a parabola is always going to be from negative infinity to positive infinity, and then the range is going to go from the vertex to either positive or negative infinity. All right, so this is it's going to be similar characteristics for even polynomials. Again, the end behavior will be the same for even polynomials. Since there's two changes of direction, the degree is going to be at least 2. And the end behavior is going to be the same. They're either going to both, as x approaches positive and negative infinity, they're either going to both approach negative infinity or they're going to both approach positive infinity. All right, so if a and b in your function, if a and b are both positive, then both of them are going to approach positive infinity. If a or b is negative, then both are going to approach negative infinity. And then we're going to use the cubic function to demonstrate what happens for most odd functions. Again, the domain for cubic functions is going to be all real numbers. The range is going to also be all real numbers. Since there are 3 change of directions, then, and that second change of direction occurs at that inflection point, the degree is going to be at least 3. The end behaviors are always opposite. If one approaches positive infinity, then the other approaches negative infinity. All right, so if A or B, if A and B are both positive, then as x approaches positive infinity, f of x will approach positive infinity. And as x approaches negative infinity, f of x is going to approach negative infinity. If A or B is negative, that's going to reflect the graph. So as x approaches positive infinity, f of x will approach negative infinity. And as x approaches negative infinity, f of x will approach positive infinity. A real quick review of interval notation. Parentheses means that we are excluding that number next to the parenthesis. The brackets means that we are including the number next to the brackets. So in set notation, if we have y is greater than 2, in interval notation that would be parenthesis 2, comma, infinity, parenthesis. You should always have parentheses next to infinity symbols. And then the smaller number should always be on the left. Bigger number should always be on the right. For y is less than or equal to 5, we should have parenthesis, negative infinity, comma, 5, and then a square brackets. For negative 2 less than y is less than or equal to 5, we should have parenthesis, negative 2, comma, 5, and then square brackets. And then for negative 6 less than or equal to y less than negative 1, we should have square bracket, negative 6, comma, negative 1, parentheses, since we are not including the negative 1, and we are including the negative 6. All right, so for this first example, we've got the following polynomial. The lead coefficient is 1. The degree is 5. It's the highest degree for the monomials. As x approaches positive infinity, f of x is going to now, this is, 5 is odd, so this is going to be an odd function. All right, so it's going to mirror, the end behaviors are going to mirror that cubic function. Now normally, if as long as A or B, A and B are both positive, or the lead coefficient, if the lead coefficient is positive, then it's going to mirror the end behavior of the x cubed. So as x approaches positive infinity, f of x will also approach positive infinity. And as x approaches negative infinity, f of x will approach negative infinity. The domain for all odd functions is going to be all real numbers. And the range will also be all real numbers for odd functions. All right, example 2, the lead coefficient. The lead coefficient is going to be the lead coefficient is going to be negative, because we know that the function is going to be even because both of the arrows are pointing the same direction. That occurs with even functions. All right, and since both of them are pointing down instead of up like a quadratic function, a parabola, we know that the lead coefficient is negative, and the degree is going to be at least 1, 2, 3, 4, since there are 4 changes of direction. Again, 4 is even. And as x approaches positive infinity, we can see in the graph that it's approaching negative infinity. And in the graph, we can also see that as x approaches negative infinity, it also approaches negative infinity. The domain for all even functions is going to be all real numbers. And the range is going to be the highest that this graph goes is positive 5. So it should be all the values equal to 5 or less. 1, 2, 3, 4, 5. It should be 5. And we are including the positive 5. All right, now these are in intercept form. In this form, with the factors being multiplied out, that allows you to see where the x-intercepts are. The lead coefficient is going to be negative 1/3. So that's going to reflect the graph. And we've got 1, 2, 3, 4, 5 x's. So that's going to give us a degree of at least 5. And 5 is an odd number, so it's going to be an odd function. So the end behavior, one is going to approach positive infinity, the other one's going to approach negative infinity. Since it's reflected, because since the lead coefficient is negative, we know it's being reflected. So normally, as x approaches positive infinity, it would approach positive infinity. But since it's being reflected, it's going to approach negative infinity. And then the opposite will happen as x approaches negative infinity. It's going to approach positive infinity. The domain and range for all odd functions is going to be all real numbers. And then this last one, the lead coefficient is 7. And the degree, there's 4 x's, so the degree is going to be 4. 4 is even. So this is going to be a graph of an even function. So the end behavior is going to be the same for both. Since the lead coefficient is positive, it's not going to be reflected. And both of them will approach positive infinity as x approaches negative infinity and positive infinity. The domain for all even functions is going to be all real numbers for all even functions. And then the range is going to be, you're going to use Desmos to identify the range. Just type the equation into Desmos and identify either the lowest or the highest point. Once I type this into Desmos, I got negative 461 as that lowest point. So the graph is going to, and the end arrows go up forever and ever on both sides. So it's going to, the range is going to be all the values from negative 461 all the way to positive infinity.